there are multiple types of reachability. The main question that we need to ask is, what is the value that it brings, right? And the value is essentially focusing you on the risks that matter the most, right? It's not perfect. Definitely, every company has its own term of reachability. You can determine reachability by having an asset exposed to the open internet. You can have reachability based on an API exposed to the internet because someone or maybe someone calls this API. On the flip side, you have another piece of reachability which is also in the source code. And there's even in the small world of problem of software composition analysis compared to everything in application security, even there you have a distinction between reachability within runtime versus source code.
Welcome to the season 3 of The Elephant in AppSec, the podcast to explore, challenge, and boldly face the AppSec elephants in the room. I'm Alexandra, your host and AppSec enthusiast and growth manager at Escape. Today, I'm joined by Nir Valtman, CEO and co-founder of Arnica and ASPM platform with a Pipelineless approach. Before founding Arnica, Nir led product and data security at Finastra, established security at Kabbage as CISO, and headed application security at NSCR. He's also a well-known speaker at top security conferences including Black Hat, Defcon, RSA, BSides, and OWASP. In this episode, we unpack the reachability hype. Why every vendor claiming we do reachability means something different. And what makes Pipelineless Reachability Analysis stand out. We'll also discuss why reachability is critical for vulnerability prioritization, plus some eye-opening stats like why developers prefer scan results in under 30 seconds and how 9% of detected vulnerabilities still make it into production, even after developers are notified on push. If you enjoy this podcast, don't forget to subscribe and follow it on your favorite podcasting app or YouTube. It's the best way to avoid missing future episodes. With that, get ready to hear Nir's opinions. Dive right in. Hi Nir, I'm super excited to have you on the podcast with me today. Thanks a lot for finding time and joining. I think we're going to discuss today a topic that's very hyped now throughout the last months for sure. Which is reachability. When I saw, in your LinkedIn post about it, how it is, hyped in AppSec at the moment. There was Gartner talks about it, and when I think James Bertotti also released the newsletter in a couple of months ago, and there are just so many different types and definitions that exist that unless I, with the less security experience, kind of get lost in all of them, trying to understand what are the differences. And for example, James mentioned 5 different reachability types, and also did an article static versus runtime reachability, basically a code or runtime, and also sometimes I think argued that it's a marketing term. Like everyone argues that shift left is a marketing term, so I think now it's time for reachability, I guess. And yeah, as mentioned, like every vendor says that they do it, and I know Arnica does it too, but it's for everyone. It's also something slightly different, and I think for you, I guess, what do you think? What is your definition of that? And do you actually think, like James, that it's very hyped right now?
Yeah. So first of all, thanks for the invitation, Alexandra. I'm super excited to be here. And yes, there are multiple types of reachability. And as you mentioned, you have the runtime, you have, the other capabilities. The main question that we need to ask is, what is the value that it brings, right? And the value is essentially focusing you on the risks that matter the most, right? It's not perfect, and we'll talk about it later on. We'll dive into this, but in essence, yes, definitely every company has its own term of reachability. You can determine reachability by having an asset exposed to the open internet.
Yeah.
You can have reachability based on an API exposed to the internet because someone or maybe someone calls this API. Maybe it's a known API versus not a private API. And a private API, even if it's not documented, is it reachable or not? Again, it's a question that you can determine based on the traffic that you can see. On the flip side, you have another piece of reachability, which is also in the source code. And there's, even in the small world of problem of software composition analysis compared to everything in application security, even there you have a distinction between reachability within runtime versus source code. And so, for example, on the runtime side, there are some companies that it may fit them better than maybe the code, some other companies that the code will fit them better than the runtime. And the reason is because typically when you look at runtime reachability on software composition analysis, and I have a few companies that I really like in this space, it actually tells you what is being loaded into the memory, and then they can look at the functions and tell you, hey, is this function is being called?
Yeah.
And it's great if you have the same technology stack in the company. Let's say you're 100% containerized. Awesome, you can go for this. Reality is that many companies, especially when you go to the higher tier of those enterprises, they have other things. They have VMs, they have serverless functions, they have other workloads that you can't really, maybe even no code. You have other workloads that will not be protected by utilizing this approach. So in that case, you do have a gap, which you can complement with the source code side. Okay. There are additional areas, like let's say you have an SDK that you want to release. And SDK is one of the pieces that you provide to developers. Let's say you're a company that you want to give an SDK. Even in that case, it's not really in runtime, but it's a package that you release to others for them to use. So is it important? Maybe it's not. Well, probably yes. This is why not only the coverage of the infrastructure, but also any internal packages or those that you will expose externally are the ones that you need to cover with a source code based reachability.
So basically the ones that are being called, being used, and this is the main definition.
Yes, but it's even further than that. So maybe let's take the different maybe levels of depth in the source code reachability. So the first level is really identifying whether you import the package into your source code. And the import of the package is fairly simple with some languages, like an NPM based packages. Yeah, it's like, this is the name, it's obvious. It becomes a bit more complicated when you look into languages like Python, because in a Python, whatever the package that you installed is not necessarily the name of the package that you import. So you need to have this type of mapping. Annoying problem to solve, but it can be done manually, completely fine. I mean, this is piece of the sauce the companies actually have, right? Then you can go one level deeper and you can ask, hey, in my imported packages, is anything imported there? In the third party packages and the fourth and the nth party packages. In that case, the value is a bit lower. It's not that you have an exponential value when you go up from import level in your source code, import level in nth party code, but it's still something that you can have an insight for, again, fairly easily.
Let's go. It's easy to go to so many levels actually of the packages to find out what is being used and how vulnerable.
In certain languages, yes. In certain languages, it is, because at the end of the day, the world of problem of packages with CVEs is limited. It's not that you need to look at 10 million packages. You need to look at a couple of thousand of packages if you care about, let's say, high and critical severity vulnerabilities. So it's not as big of a challenge to do this work manually. Now, when you look at the import of the imports in an nth party package, then you can automate this with specific languages like NPM based, but with Python, that's going to be challenging. And not sure that the value will be high.
Interesting, yeah, because I did a lot of coding in Python during my university years and for data science as well. Then never thought about like the actual packages that I've used, how vulnerable they might be, or to what level, how hard it is to actually analyze.
There are some challenges that come out of inconsistencies. The one that I mentioned is the naming of the package is one. You have other inconsistencies, such as you have a package that don't necessarily have a GitHub repo associated to this. Okay, so how do you map this one? Some actually have packages on their own website without any connection to Git. Again, this is where the nitpicks come into play, but eventually it's a world of problem that requires research.
And what about JavaScript, for example?
So in JavaScript, it's easier. So if it is managed in npm, It's way more standard, especially since Microsoft took over.
Okay.
There are unmanaged dependencies, which is an additional thing that should be looking at. So, for example, I'm just throwing something out here: jQuery. And in that case, you can actually see many companies where they just embed the JavaScript, the minified JavaScript, into their source code. And you don't download it from a package manager. So in our case, we do have a technique to identify those unmanaged packages and do the same analysis there.
Okay.
Again, it's a manual work that requires the mapping because you need to look at the signatures of those files, and based on the signatures, you determine what package it is.
Okay. And is there a way to automate it?
It's a manual mapping that essentially you just continue to maintain.
Yeah. Okay.
But this is only import level. Now, the moment that you go to the next level, which is, let's say, function level reachability.
Yeah.
When it comes to function level reachability, it boils down to what is the function that it is exploitable.
Yeah.
And the CVE, or most of the CVEs themselves, they don't really expose this data.
Yeah.
We ran multiple attempts before we realized that we'll need to do this work manually in manual research. But the first research that we did was actually looking at the descriptions of the CVEs. Then we went to each of the descriptions, tried to figure out what is the function level reachability there. We did get some data from this and validated this manually. Then we went to the, you have references in each CVE. So we went to the commits and the code diffs and the blobs that were changed with the fix, and we analyzed the source code there to figure out what is the vulnerable function. That had very partial success, like very low success rate, and the reason is because in many cases, if you think about the source code, you have a public function that calls sub-function that calls sub-function, and the fix is somewhere in the fifth level function. So you need an AST to understand what is the public function that someone will call to get to that code change that is published with a code diff in the references.
Okay.
Again, I didn't solve it for us.
Yes, I mean, it does sound like a lot of manual work and manual research. I totally understand that. I'm right now also doing some security research on the Scape site and analyzing all CVs and mapping it to CWEs and trying to get a hand of it. So it's even now with ChatGPT, still you have to trust by verify. In this case.
Exactly.
But how, for example, for you, does exploitability of actual CV does it play any role? Because I think CISO kind of defines that, how as actually this vulnerability being actively exploited or not. Does it play any important role for you?
Yes. So there are multiple factors at least when we prioritize the severity for each vulnerability. Obviously, we look at the reachability level. By the way, reachability level, it's not only whether you use the function, it's also how do you use the function. Worth mentioning. This is very important because let's say you have a function that runs an SQL query. If it doesn't have any parameters, it's not a problem because you don't have the user input. And if the CVE requires the user input, then it's not exploitable. Or sometimes we found functions where you can call a sanitizer within the function. And if you call the sanitizer with the flag of true, then it's no longer exploitable. So we actually read the workarounds, and based on that, we develop the rules.
Okay, interesting.
Because if you call the function, you will eventually get, hey, this is exploitable, and then the developer will look at this, and you will lose the confidence from the developer. So this is why the workarounds are very important, because the developers also get into those details because they challenge everything security brings to them.
Yeah, that's actually very true, because I think one of my podcast guests, he keeps on telling, because he also was at the event that organized how developers are divas, that's his favorite expression. So because they're very, I think we also discussed that when we had the initial call together. Like, it's the most opinionated group. How do you actually get them on board when you talk about reachability and the concept? Do you actually explain that to them, or like do any trainings on how to create function, call function, then how the tools actually analyzing that?
So it depends on the time. So at the end of the day, it depends when you actually notify the developers about something that you ask them to do. Everyone talks about, cloud native app protection.
Yeah.
But this is great for the technology. But in our case, we're really focusing on the developer native workflow. And the developer native workflow is completely different than the cloud workflow. The developer native workflow, in what sense?
Yeah.
So the developer native workflow is a workflow that essentially makes sure that the developers can get private feedback only on the things they are asked to act at the right time. Meaning, if you think about it this way, you clone a repo and you have whatever, security ID plugin, which is already an opt-in functionality, and it's already, really hard to get across the development. But let's say you have a specific developer that has this plugin.
Okay.
In this case, the developer will see a list of, highs and criticals they need to fix. Let's say, 20 highs and criticals. You don't need 5,000. You just need 20.
If you succeed to fix 20 within more than several weeks, that's also good.
But even the 20, as a developer, I'll look at the 20 and I won't know what to do with this. Like, which one of the 20 is more important for me to focus on right now? I don't know. Do I need to fix it? Am I even equipped to fix it? I don't know, right? I'm not measured on this for sure.
I mean,
So
it depends on the companies, actually.
it depends on the company, of course.
There are things like wall of shame that can actually help.
We can talk about that. I had that in the previous company. Accidentally built a wall of shame, but yeah, it worked.
Okay.
So in essence, if you think about it this way, if let's say in the workflow, if the developer if you think the developer workflow is, you have a Jira ticket, you pick it up, you clone the repo or fetch the repo, you create a feature branch from a Git perspective, you commit code, you push the code a few times, and then you create a pull request, and someone reviews the code, and if you have the thumbs up, then the code is merged into your production branch, right? The happy path, okay? And in this happy path, let's say the developer actually committed some code and saved the work, pushed the code. At that point of time, if you can scan only the changes that the developer made, at that point of time, you can say, hey, dear developer, this is a vulnerability you just introduced in the context of everything that we know. This specific vulnerability will be flagged in the pull request. So you should probably fix it now.
Okay.
And this is how you see the biggest impact, because we need to assume a good intent by developers. Developers typically don't want to screw things up, right? And they will appreciate if you give them something, one, in a private manner. They don't want you to blame or shame them.
Okay.
And two,
so wall of shame did really work.
it worked in the previous company, but here we learned that we better not blame or shame them.
Yeah.
And also, if you give them the opportunity to even manage the risk or work with the risk management process in such a way that will not prevent them from merging code later on to production, then you can even get a higher success rate. And by saying this, think about the workflow from a security standpoint. Let's say that a developer flags a vulnerability, and it doesn't matter. It can be SCA, SAST, whatever vulnerability it is, right? And a developer says, you know what, this is a false positive, because this is the nature of security tools. Sometimes they will have false positives.
Sometimes too many
In
devs
that,
in certain cases.
sometimes, exactly, sometimes. And in that case, the developer will have the opportunity to say, you know what, this is actually a false positive. I want to dismiss this one. And in that case, if you can have a workflow to even send it to the security team for approval, or maybe if it's what we see also in part of our customers is high and critical goes to security for approval, and medium goes to a peer developer to reconfirm that this is a false positive. And it's great for compliance because you have a peer review on a false positive. And in that case, by the time that you get to the pull request, it will no longer be a risk that will be flagged there because it will be addressed way beforehand.
Okay. How much time should you allocate to get this risk addressed? Because you mentioned like now, but now, especially at large scale organizations, it's very relative, I would say. It's how much time do you think is realistic and a good, benchmark maybe for people who are listening, for them to understand, okay, maybe in my organization, this is something that we're doing is correct, or
So that's exactly why we do this on push. And of course, we have the capability on the pull request, but I'll tell you what doesn't work to get back to what actually works. What doesn't work is there's a lot of companies saying, hey, you have the 100% coverage with code risks, and you'll have the scanner that will flag things on the pull request, meaning you can fail the status check, you can annotate on the pull request, whatever it is. The problem with this is that the developer already wrote the code, right? And only in the pull request the developer sees the first time the vulnerabilities that need to be fixed. Now, if it's enforced from a security standpoint where you have a mature process, if it is enforced, then the developer cannot merge the code unless they need to have admin rights to bypass or such. So if they do need to ask, if a developer needs to ask a, let's say, false positive acceptance or check the box. Most AppSec teams that I heard of, I actually heard about only less than a handful of AppSec teams that actually have an SLA to respond to the developers. Most application security teams don't really have this SLA, which is the thing that delays the developers.
Okay. Do you think they should have?
If you own, as an application security, if you own a mandate to block the development process, in my opinion, you must have an SLA to respond to such requests.
Okay.
And by saying block, I mean hard gates, not the soft gates, right? Because a soft gate, you can still flag things to the developers, but not block them from merging code. Now, this is where, back to your original question, this is why the notification on push and getting the developer to say, I want to dismiss this is something that can be done, a day, 2 weeks, a month, depends how long it does it take to develop the feature before the pull request. So it gives the AppSec teams more time to respond and review those vulnerabilities or requests that come from the developers.
Okay. So it kind of makes their life easier.
Way easier. And as an evidence, just to kind of explain the difference, what we noticed is that the moment that, for any vulnerability, and this is across all tenants, we analyze the data across everyone to figure out how certain features actually work in the product. We learned that if we notify the developer on push, 66% of those issues will not appear in the pull request at all. So if you ask, the efficiency of notifying on push versus notifying on a pull request, it's better to do it on a push.
Okay. Interesting.
That's pretty much the benchmark. Now, with the same approach, because you don't piss off the developers, there's also a lower merge rate of vulnerable code. And so the question is, what happens from the moment you detected it on push up to the pull request? This is one, only third is getting to the pull request, right? And then the question is, from the moment, if you notify the developer on push, how much actually ends up in production, meaning merged with a pull request? And the answer is average in our case is 9%. Okay. To give you a comparison, other companies that I've seen before implementing this functionality were north to 45% in merge rates. And the reason is because it's too late in the pull request.
Okay, interesting.
So that's the thought process. So this is the workflow, right? But Within the same workflow, you must have the specific scanner capabilities that give you the ability to scan fast. Some developers have very short attention spans.
Okay. I think once you're in the flow as well, you kind of don't want to exit it.
Yes. The thing is that if you push code, you don't want to wait 15 minutes for a scan to be completed. As a matter of fact, you don't want to wait even a minute for a scan to be completed. And it's hard. It's hard. The way that we found the sweet spot, 30 seconds is the sweet spot that we found for a developer to be fine for getting the results.
How did you measure that?
We measure through analytics to figure out where do we have better engagement rates.
Okay.
And this is when, at least when we see that an on-push scan takes more than 30 seconds, we prioritize more performance and more performance work to figure out how can we go, sub 30 seconds.
Okay. Do you measure, like net promoter score or something like this afterwards?
Not really, not yet, but it's really high level analytics. We learned that there's some better engagement rate, and because the net promoter score, it's kind of we need to be more asking as a survey how they would do this and how would they promote us. This is based on actions.
Okay. So the actions that, for example, what you mentioned is what Arnica does when you implement the actual tool within the development workflow?
Yes, this is pretty much what we do. Of course, we bring the scanners, which is, we spoke about reachability. There are other ways to prioritize the work for the developers. I mean, we mentioned, the workflow, which is, of course, great. This is pretty much where we get the adoption. But also, there are some things that developers will know to criticize and some things that developers will not know how to criticize.
Okay.
So, for example, let's say that you notify a developer about an SCA vulnerability, super reachable, and it has, you have it all over the code, and you have also a, let's say high CVSS score.
Yeah.
But what if this package doesn't have a fix?
Yeah, I think I don't know. Usually then
So-
you have to research on it, or I think the goal of developers, software engineer, in general, engineers to find solutions to the problems. So I hope if they're patient with that, they're going to find the solution how to.
In many cases, there is no solution.
Okay.
And that's a problem, right? And therefore, what we have seen as a very common, workflow is you can notify the developer about it, but not block the developer from taking this code to production.
Okay. Even if it's a CVSS score more than 7, though very high. Okay.
Yes. And this is where they need to justify it and say, hey, I know that this is a high risk, but these are the steps that I implemented to maybe mitigate this to some extent. So the package is going to be vulnerable. The function is probably going to be vulnerable, but you set maybe additional guardrails before, merging that code to production.
Okay.
This is one way. And by the way, this is where we have a split. Some customers say, I don't want to notify the developers at all when there's no fix, and because they don't want to create any noise. Some companies actually say, you know what, I want to notify them about everything.
Yeah.
And they're smart enough to make that decision.
Okay, so you think people should be in the second basket and they have to notify?
This is like when we run Arnica on Arnica, we notify the developers on everything. But not every company is willing to do that. It depends on the AppSec team and how strong they are and how much they're willing to pick up those. Essentially, the question is, how do I, as an AppSec engineer, look good in front of the developers? And how do I make my job successfully?
So how?
And there's a balance. There's a balance, right? So some teams will push back on the developers and say, you need to figure out, how to get a guardrail in the middle. And some, security teams just not feel comfortable enough to notify about things that don't have a fix. And
why don't they feel comfortable? Do you think it depends on the seniority of AppSec teams, on the maturity of organizations?
It depends on how much work they generate for the developers. So if they think that they apply other more aggressive policies, they can lose a bit on this one. So for example, you can say, I want a bit more aggressive policy in SAST and have less aggressive on SCA to kind of balance how much notifications the developers will get.
Okay, interesting.
So again, you don't want the developer to get 20 results. You want the developer to get like, what do I need to do now?
Issue because you have basically the results from all the security tools, so you have even more vulnerabilities, but I should have like SCA that you mentioned, that size, DAST, security, everything. For everything, you have to fix something, and I think that's was definitely still is one of the challenges that are being trying to get solved for sure. But it depends. I think it depends so much, at least in what I've seen, a lot on the maturity of organization and the size of the team, because I've seen teams at the large US banks that basically had 1 year to build their own SPM solutions in place because they had time, and wow.
That's what we did in the previous company. We built our own ASPM, and it didn't have to be fancy. I actually wrote that code, so we actually connected to all of the AppSec tools that we had in the company, and just pulled everything into a SQL database and exposed it on a Power BI. And then I created views for the GMs, for their product and directors, and then security champions, and it was like every persona had a view. So it was really interesting. Maybe one thing that I didn't mention. So I mentioned that there are things that developers will be very opinionated about, which is
always the case.
has a fix, no. Has fix, no. Doesn't have a fix, yes. There is another area that it's somehow close to the reachability topic.
Okay.
So reachability, we spoke about the internet facing and function level, and of course, fine, it's all good. The additional vector or two vectors that we should be able to look at is, one, is it even interesting to be exploited? Meaning, so there's a semi-hype around EPSS, and EPSS essentially tells you it's an open source threat feed, essentially, and incident response companies report into this threat feed, and they tell you which CVEs are being exploited. So based on this threat feed, we learned what is more exploitable, what is less exploitable in the wild. Of course, a vulnerability that was just released yesterday will probably not have the top exploit rate, but give it a few days, it will look very red, like Log4j, right?
Yeah.
And therefore, you can also think about this as another prioritization method, or combine this with reachability as a prioritization method to tell, hey, maybe it's reachable, but there is zero interest to exploit this. You know what? Maybe we'll reduce the severity from high to a medium.
Okay.
That's an example of reprioritization. And another way to prioritize this would be through the dependency tree that you have. So for example, let's say that you have Spring Framework in Java. And Spring Framework brings a lot of other sub packages. Let's say that you have a vulnerable package 7 levels deep, and you don't call it in your source code.
Okay.
You can make assumptions.
That's what I talked about in the beginning, like how hard it is going to be to access all levels throughout.
Exactly, and therefore you can make assumptions about that, and also kind of say, oh, I want to look at the ones that have higher likelihood to be there. Again, there are exceptions, because for example, with Log4j, you just need to import Log4j, and it is exploitable. That's it. Like there's no function. It's exploitable. So there's a mix that can be applied here, if that makes sense.
It does, but what I also on the podcast, I really like a bit controversial questions. That's kind of the main theme. When do you think the reachability is actually looking at reachability as one of the prioritization metrics is actually hurtful? Or is it hurtful in any way, or can introduce some noise?
I think that one of the biggest challenges with reachability is not to determine whether something is reachable, but to determine whether something is not reachable.
Okay. What do you mean by that?
So, for me to find a function, it's fairly easy. And I can have false positive there. But if you prioritize your work based on what is reachable, and I told you something that is not reachable, you have a real risk that your security vendor did not provide you this information. So when we are kind of determining the reachability, we have a lot of thought process into why is it not reachable.
Okay.
And how can we tell that it's not reachable? And therefore we kind of have what we developed with our own feature. We called it reachability confidence. And the reachability confidence is, hey, like we know that it's right, the right function and it's used the right way. This is great. Maybe, hey, we saw a similar function and we believe that, it smells like the function, but maybe it's not exactly used the way that we expect it to be used. So you should take a look at this. Another type of a medium reachability confidence is, let's say, I'll give you an example let's say you have a code that is deployed in production. You have version X. Version X has certain vulnerabilities, but it doesn't have another vulnerability that doesn't have a fix. Now, the developer decided to make an update to the package to fix the vulnerability. And maybe you have 5 criticals in production, and this fix will make it 1 critical.
Yeah.
At that point of time, you may have a lot of code changes already in a non-production environment.
Yeah.
You can look at the code, and the code will tell you, hey, there's no reachable function right there. But if we find that you use this function, let's say in your production branch, we'll tell you, hey, we have a medium confidence because it's not in the same branch in Git, but there's high chances you will merge there and it will be reachable. So this is why it's important. This is what we call the pipelineless reachability. So we spoke about the complexity of that world. So therefore,
it's very hard to distinguish between the signal from the noise. And I think question actually that probably every AppSec engineer asks themselves, and you as a former background as the AppSec leader, how do I sort through all the tools that tell that they're doing reachability analysis and actually focus on and can actually see the ones, distinguish the ones that are doing it from a technical point of view. And even before I engage in POC, because POC is still kind of time effective. You have several meetings, that was before that. So how can I actually sort through that noise and decide that the tool can bring me value in terms of reachability analysis?
I think that it's a few steps. So first of all, every company needs to identify which languages they use because the reachability is typically language dependent. So figure out which languages you use, then find some of the GOAT projects. It can be, whatever, GOAT projects that you have that are essentially vulnerable applications. It can be a vulnerable Terraform. James from Latio also has its own repo that is very nice. And, you have them vulnerable C app, you have REST and Nest-specific applications and Java and C#. You have different GOATs. Create the simplest way, create a trial GitHub organization, enterprise or something like this, or even free, and just fork those repos.
Okay.
Then bring the scanners that you want to test and compare the results. And you will see the discrepancies in what is reachable. You'll see the discrepancies in how findings are being reported. So for example, some products report by vulnerabilities. Like what we do in Arnica, when we see as frequent in POCs, customers say, hey, we have less vulnerabilities in Arnica. Like, of course, because we aggregated to the fix of the developer. Like, what can the developer do about it? We aggregate, and you can see 20 vulnerabilities, 1 fix. This is 1 finding. So it's kind of, when you see those repos, when you see the scanners, this is when you need to do the comparison and see what works better for you. Because one product that is better in NPM may be not as good as maybe another product in, I don't know, in Java, whatever.
So it really depends on the framework or on the language that you're using, and then you have to compare it and see for yourself.
Yes, and at the end of the day, there's also the question of like what is good enough for you, right? Because nothing will be perfect. I promise there's no.
If you're a perfectionist, you can't work in security.
Exactly, and therefore, if you're kind of figure out what is the minimum value that you're looking for, because sometimes you may say, you know what, I'm fine with import level reachability, and that will reduce like 20% of the risks that I have, and it's good enough for me because I don't have that many risks. Or maybe, we even have customers that we introduced to them reachability, and they said, oh, we don't care about the reachability. Our policy is if this is medium or high, you fix it.
Okay.
And that's it. Medium and high. Yes, everything has SLA. So the specific one, for example, that I'm talking about, the policy is 0 criticals and highs and 0 new mediums.
Okay. Well, new depends how old is new, because I see
New as of
things.
Not yet in production.
Okay.
And kind of blocking the introduction of medium severity vulnerabilities into production.
I see. Okay.
Yeah.
And there's always one question I ask at the end of the podcast. What book would you recommend to someone who wants to learn more, maybe on the topic of reachability or application security?
So I'm less on the security books. When I'm reading books, is mainly documentary things, or just things that kind of make you think a bit different.
What do you have an
So
example of the book?
the series that I love is Freakonomics, and Freakonomics essentially awesome trilogy of books that essentially tell you about different stories that happen in the world, and how, if you think about it from a bit different direction, you will see that there's other factors that impacted such a change. So that's definitely one of those. And there's also a podcast that I'm listening to that is on a different direction, closer to our world. It's called Acquired. And Acquired, every episode is 2, 3, 4, 5 hours now. So it's long episodes, like listening to a book.
Wow.
Yes. And they have different stories about how each company succeeded. They have the Nvidias, Microsofts of the world, Meta just released, through other companies like Lockheed Martin and Nike, and so it's really interesting to hear the stories about how those companies evolved to what they are today.
Okay. Very interesting. Maybe I'll check it out. Probably not 5 hours. 1 hour is fine. I think I'm definitely more book person. Like I've read, a Nike story. I love to read biographies in general. So that's something I could try to see and listen, and maybe it will be useful for some of the listeners as well. Thank you so much, Nir, for coming on the podcast. It was a pleasure chatting together. I think I've learned a lot about reachability, about how it can be put in practice into development workflows, and what's important for development workflows as well. So thank you so much.
And thanks for the great conversation, Alexandra.